Welcome back, students. Today is the session number 3 from the chapter Work, Power and Energy, and the topic is the Work Energy Theorem. Now here I have written that for a rectilinear motion under the constant acceleration, the equation of motion is given by v square minus u square is equal to as. जहाँ पे v क्या है? V is equal to the final velocity. I think everyone must be knowing this equation of motion, and u here is the initial velocity. A is the constant acceleration. And S is the displacement. So now we will just we will be just using this equation in order to derive the work energy theorem. So v square minus u square is equal to 2as. So what I am now here doing is I am just multiplying both the sides of this equation by half m. That is multiplying both sides of the equation by 1 by 2m, where m is the mass of that object. So हमें यहाँ पे क्या मिल जाएगा? We will be getting half m v square minus half m u square, which is equal to half m 2as. ठीक है ना? ये हो गया. So इसको हम क्या लिख सकते हैं? Now this can be written as, now half mv square is what? This is the kinetic energy. So the kinetic energy of that object, you can say this is the kinetic. It is the final kinetic energy of an object, which I am writing it here as kf. ठीक है? And this is the initial kinetic energy of that object. ठीक है? So this can be written as k. I am writing here as ki, and this is equal to half m 2as. Now this can be written as, if I just simplify it, then we will be getting as m in dot a dot s. ठीक है ना? Now जो ये है this kf minus क्या है? This is the change in the kinetic energy. So हम kf इसको हम लिख सकते हैं as delta k. If delta k is the change in kinetic energy, then delta k will be equal to kf minus ki. ठीक है? So this is the change in the kinetic energy हो गया. And now what I will do is, so this equation, this one, let us say this is equation ऐसे लिख दिया मैंने as 1. So this equation can be written as delta k, which is equal to m dot a dot s. Now we know that the force is equal to mass into acceleration. So this m dot a can be replaced by f dot s, where F is the applied force हो गया, and S क्या है? This is the displacement of that object. ठीक है. नाउ हमें ये भी पता है, नाउ वर्क डन इज इक्वल टू फोर्स इनटू डिस्प्लेसमेंट, ये भी हमको पता है. इसको मैं यहां लिख लेता हूं नीचे. नाउ वर्क डन जो है, वर्क डन इज इक्वल टू फोर्स डॉट डिस्प्लेसमेंट. ठीक है. सो दिस इक्वेशन can be written as delta K is equal to work done by the applied force. ठीक है ना, this one. So the change in the kinetic energy is equal to the work done by the net applied force on that particular object. So we have derived this work energy theorem by considering the equation of motion for a rectilinear motion under the constant acceleration. That is, we have used the equation of v square is equal to u square plus 2as. यही हमने यूज किया था. तो हमने क्या किया था, u square को हमने इधर ले लिया था. That is ultimately what we have used this equation, that is v square minus u square, that is equal to 2as. So इस equation of motion को use करके what we have done is we have derived the work energy theorem, which states that the change in the kinetic energy of an object is equal to the work done by the net force applied on that particular object. So this is a very, very important theorem, and we will be using this theorem in a number of questions which we will be doing in the forthcoming sessions. So in the next session, that is in the session number 3, I will be taking up a couple of questions which will be based on the this work energy theorem and the work done by the variable force. So thank you very much for joining this session, and have a nice day.